I'm live, it says. Howdy, stream is starting. Excellent. Cool. It looks like we're going. Go to the calculustutor.com/live to submit homework problems. We'll do the intro here in a minute. I need to actually get the website updated, though. I forgot to do that before I started. It's one of those weird things where when you have things like partially automated, right? It's hard to remember what things you need to do and what things just get done automatically. All right. Do you hear my cat? I just have to update the banners at the top of the pages. Her name's Destroyer, my cat. And despite her name, she's actually very gentle with things. There we go. Easy peasy. All right. I think we're started. I think I can get rid of that. Completing the square, question mark? We'll come back to that. We'll start at the top, just like we're going to start doing it at the top of every stream. Abolish ICE. That's it. Exactly as it sounds. We don't need ICE. Get rid of them. We can figure out other ways to enforce our immigration policies, but we don't need ICE. even if you're a young person, younger than 18 and you can't vote, you can still call or send messages to our representatives. And I encourage you to. They don't hear from young people very much, so a young person reaching out to them would be impactful. So, and I don't care what what your political opinion is about anything. If you feel strongly about it, reach out to your representatives. You can use fivecalls.org to find your representatives and get their contact information. Yeah, if you feel good talking on the phone, oftentimes you just get voicemail, so you can just leave a message, but they all have ways to send them messages through their website. So yeah, I encourage you to do that. Yesterday I mentioned that Springfield High School students had joined South Eugene students at the Federal Building, and I misremembered. It was students from Sheldon High School, another Eugene high school. So shout out to Sheldon high schoolers alongside South Eugene high schoolers and Monroe middle schoolers who all engaged in walkouts yesterday. It's fantastic to see. Y'all are awesome, and I admire, respect, and am proud of you. Yeah. Should we get the stream started? Should we do our intro? So, hi, I'm Ryan, the calculus tutor. I'm here 3 times a week to answer your math questions live, but the questions I answer live, you don't have to be here to get those answers. After the stream, I email links to the place in the notes and the place in the stream recorded VOD where I answered your question. So if you send in a question, I'll answer it during the stream, but then after the stream, I'll send you links to where you can access my answer, both the video and access these notes that you're seeing right here. I'll send you a link to this very document so you can scroll around and go right. And I'll send you a link in the document. It will scroll you right to your right to the answer, the link I send you, but then you're free to look around if you want to look at other stuff too. How does this work though? How do you submit a question? It's a good question that you're asking right now. So let's talk about it. So you go to thecalculustutor.com/live. That will take you to this page. If you just go to thecalculustutor.com without the /live, that just takes you to my homepage, but that's totally fine. You could click the link or the banner up top here to get back to that live page. You can see the stream is here on the homepage as well as a submit a question button. Those are all places you could click to get to thecalculustutor.com/live. My cat's running around. I told her I was starting my stream and she had to be chill. I don't know if you can hear her. So once you're here on this page, you scroll down a little bit. There's a submit questions button under math live streams. There's also a submit math questions button here. This question submission, this will take you to a form, but as you can see, you can also email your questions to me directly. Ryan@thecalculustutor.com is my email address. But let's click I prefer you use the form. So let's click the form and see what happens. For me, it loaded up the form right away. Oh, shoot. You all can't. Hold on a sec. Let me go back. I just realized you all have a black screen. I apologize for that. I have to whenever I change my screen share source, I have to tap the stream to make it say, hey, make sure you're showing that. Anyway, so yeah. Once you get here, and you can get here from my homepage as well, scroll down, there's a question submission form button. Tap that. We'll pop over to that tab. Now, for me, it loaded the form right away. For you, it might pop up a Google sign-in screen. You can submit images on this form. That way you can submit pictures of your math problems. And Google requires that if people can submit files on a form, those people have to be logged into a Google account. So, however, the advantage of that is I get your email address and I can email you the links back even if you use the form. So, pretty easy. If you try to use your school Google account and it won't let you in, I apologize. That's just because your school has your Google account locked down. Go ahead and email your question to me, ryan@thecalculustutor.com. Everything I'm asking for here would be a good idea to include in your email. Yeah, so the form's just sort of a guide. It keeps everything all nice and organized for me, but absolutely feel free to just shoot me an email if that's easier for you. But yeah, let's go through this. You can see you have to check that your email address is being recorded, as I've just mentioned. And then very first thing, who are you? Whatever name you'd prefer. It doesn't have to be your real name or your full name or anything like that. Just however you'd like me to refer to you when I, shout you out on the stream that I'm answering your question. You could include your pronouns here as well. If you don't include pronouns, I'll probably just use they. And then the next box, where did this question come from? I assume most people sending in questions are going to be in a math class, and they're going to be questions from their math class. So the idea of this is you just tell me the teacher in the class. Mick Smith's Geostats, Mr. Anderson's Algebra 1. Simple as that. If it's not from a class, you can just tell me that. You can just tell me, oh, it's not from a class. It's from my work or from my life or whatever. All right. And now here's where you ask me your question about the math problem you're going to send me. So a little bit further down, there's a place where you can attach images of your math problem, and we'll talk about that in just a second. So just know you don't have to retype the math problem here. That's not the point. This is for you to ask your actual specific question. And if your question is just, can you show me how to do this? That's totally fine. I would love to show you how to work through the problem. However, the more specific you can be in your question, the more specific my help can be. So if you in your question, you tell me, hey, can you show me how to deal with the fractions in this problem? I'm still going to work through the whole problem, but I will know to focus on the fractions. Or, hey, can you help me with the graphing of this problem? Again, I'll do the whole problem, but I'll know to focus specifically on the graphing and to point out things about that. If you just want me to go through a problem, I'll do my best to sort of, address what I know are, common hangups and stuff. And if you can catch the stream live, you can ask clarifying and follow-up questions in chat. That's awesome. And if you're not able to catch it live, once I email you stuff back, you can just email me back follow-up questions or clarifying questions, things like that. So there can be a bit of a back and forth about this. But yeah, you just tell me what your more specific question is. This is also a really good place for you to specify like which math problem in particular. You'll need to tell me that too, especially if you just send me a picture of your whole page of math problems, right? So you might tell me, number 13 or something like that, or number 13, numbers 13 through 18 if there's a whole section of math problems or something. Oops, get rid of that. There we go. And then we'll skip this part really quick to talk about the images. So if the math problem you'd like help on is in your textbook or on a worksheet, just snap a picture of the whole page. And then up here, specify which problem on that page you would like help with. But that just makes sure that things like the instructions are there. If it's like a two-sided worksheet and the instructions are on the front, just send me a picture of both sides. Easy as that. But yeah, I just need to see the instructions. I need to see the whole problem, and like diagrams or charts or tables or whatever else, little figures that are included as part of the problem. Even if those things are blank and you're supposed to fill them out as part of the problem, if they're included in your image, I'll put them in my notes, and that's what I'll use to do the problem. And that way my notes look like what's expected of you on that problem. If it's an online assignment, You could just snap a screenshot of the particular problem. If it's like a PDF packet that you're working through, you could actually upload the entire PDF so long as it's smaller than 10 megabytes. You can upload the entire PDF. If you do that in this, what is your question part, you might also tell me what page, right? You might tell me, page 3, number 12, because sometimes in these PDF packets, the numbering's not consistent because the teacher pulled questions from all over the place. They pulled question number 6 from this place, question number 8 from this place. Oh, and a different question number 6 from a third place. So there's 2 question 6s or something. So yeah. So just directing me to the problem you actually want me to go over is useful. The only other thing with the images that could be useful for you to include is a picture of any work you've already done related to the problem. If you started the problem and got stuck, or you worked all the way through it and got the wrong answer, send me that work that you did. That'll actually help me and figure out how best to help you. That's really useful information for me. If you say you're asking about problem 13, but you already did problem 12, send me a picture of your work on problem 12. It shows me what your process is. And it can sometimes inform me about how you're being taught to do things in class. If you don't have any work you've actually done on problems like that, but you took notes from class that are related to those problems, send me a picture of your notes. All of that helps me understand where you're at a little bit better, and it helps my answer be a little bit better. That's not required for you to send a picture of your work, but it does really help me. My promise to you is that if you send a picture of your own work, it will never show up on stream. That's not the goal here, right? My math work is on stream. Any math work of your own that you send me is just to inform my answer. That said, there is a little checkbox, a place where you can opt into letting me share your work on stream. Just because you check that doesn't mean I will show your work on stream. That's there for a really particular type of help that I imagine university and college students might need at some point. But if that's not you, don't worry about it. But yeah, if the type of help you're looking for is you want me to go through your work sort of line by line and give you feedback, I would need to be able to show your work on stream to do that. But if that's not what you're looking for, if you're just looking for me to work through the problem and explain it, then still please send a picture of your work, but rest assured it won't show up on stream. Yeah. That is how you participate. Pretty straightforward. Oops, wrong button. So let's go back to the notes, shall we? So it's Wednesday. Let's check and see. Let's check for question submissions. None in the form. And none. Oops, wrong button. And none in the email, it looks like. Okay. So what that means is it frees us up a little bit to just talk about some, kind of whatever topics we want to talk about. Yesterday, I worked through a problem. I worked through this rates problem, a very classic type of word problem, especially at about the Algebra 2 level. Requires some problem solving, and then it ended up going into we had to deal with these rational expressions a little bit. It all culminated in this quadratic right here that we had to solve. We use the quadratic formula, but there's another process we can use. I'm going to move that over and also make it a little bit smaller. There we go. Just that way it's not encroaching on today's notes. So I wanted to talk about completing the square, which is a technique for solving quadratic equations. So in fact, let's do that. Oops. Completing the square. So let's talk about, make this a little bigger. So we'll scoot it over. So this is a technique for solving quadratic equations. So yesterday we had that quadratic to solve, so we use the quadratic formula. That's a strategy that will solve any quadratic formula. Completing the square actually will also solve any quadratic, though for certain quadratics, it turns into something kind of complicated, but not necessarily more complicated than the quadratic formula. So, you know, you have your options there. We can also graph it, and then there's also factoring if factoring works, but not all quadratics and most real life quadratics aren't directly factorable in the way you would learn how to factor them in school. So having a method that works for all quadratics is really, really nice. Quadratic formula is sort of the go-to one. This completing the square, though, is a technique that is useful kind of in other places, and practicing it and understanding it helps you build an understanding of quadratic equations a little bit more. And so there's benefits to it beyond just the pure utility of solving quadratic formulas. So let's talk about, let's do a little bit of, let's define a perfect square polynomial or quadratic. So a perfect square quadratic is one that can be written as x, I'm going to say plus b, but b could be a negative number, which means this would look like x minus b, but x plus b squared. Just like a square number is a number that can be written as some other number squared. So 25, for instance, is a square number because it can be written as 5 times 5, or 5 squared. 16, 36, these are all the square numbers, 49. Polynomials and quadratics are just a representation of a value, a number. And so just like any number, you could have one that is a perfect square. And it's a perfect square if it can be written as a little binomial, a very simple binomial squared. Excellent. So completing the square means we're taking a polynomial that's not a perfect square and doing some little algebra moves so that in part of the equation we do have a perfect square polynomial. And the reason this is useful is because if this was equal to something, right? This is equal to some number. I'll just say a, some number, right? It doesn't matter what it is. This is very easy to solve for x. You take a square root and then you subtract b and you're done, right? And that's very useful. And most quadratics aren't that easy to solve. they take more steps. So if we can put it in this form, then we know, oh, we're only a couple steps from having the solution. So let's talk about, so this is in a really compact form, but you might know if you take the factors of a polynomial, you can multiply them out. So x plus b squared means x plus b times itself, x plus b. And then to multiply this, we do x times x, which is x squared. We do x times b, which I'm going to write as bx. And remember, b is just some number. Could be positive, could be negative. See? And then we'll also do this b times that x and times that b. B times x is another bx. B times b, that's b squared. And finally, I'm going to simplify this a little bit because we have some like terms. Bx plus bx, that's just 2bx plus b squared. And now hopefully this looks familiar to you. Hopefully this reminds you of ax squared plus bx plus c, right? This is just a quadratic in standard form, right? This is standard form. This right here, this is factored form. So we know if you have a quadratic in factored form, it's really easy to solve. A quadratic in standard form, sometimes not as easy to solve. But what I want to point out here is all we did is rewrite this perfect square in standard form. So what this does is this tells us how to recognize when you have a perfect square quadratic in standard form. And if you know that it's a perfect square, you can just skip directly from here and just turn it into that. You're like, oh, I know it's a perfect square, and so I know it'll just turn into this. So I want to point out some patterns here. Notice in this we had a b. Here we have twice b, and here we have whatever that b is squared. So what you're looking for, and notice there's no coefficient in front of the x, or rather it's a 1, right? So if half the middle term squared is the last term, then it's a perfect square. That's how you recognize it. That's how you recognize when a quadratic in standard form, which is the most common form you're going to encounter them in, that's how you recognize if it's a perfect square. And so the question now is like, okay, well, that's great. So like occasionally I'll be able to recognize when it's in standard, when I'm given a perfect square. But here's what's cool. It's actually really easy algebraically to sort of force a quadratic to become a perfect square. So let's do if half the middle term squared is the last term, then it's a perfect square. Yeah. So this is the pattern. And then notice when you write it in factored form, which is the form we want it in because it's really easy to solve from there, you end up, what the number that ends up in here is half of this middle term, right? So it's not the middle term, it's not the last term, it's a third thing, but they're all related to each other. Oh my goodness, I am so sorry. Here, give me one moment. My nose is killing me. I need to blow my schnoz real quick. fix my hairband while I'm doing stuff. Nose was very itchy. Okay. I guess here, let me do a sound check really quick. Excellent. Sometimes when I've muted and unmuted before, it's the sound hasn't come back. I've gone back and, when I've gone back to like look at a stream or whatever, I've noticed that there isn't sound for the last half of it. Hot chocolate. All right, back to the Miro board. So yeah, this is all well and nice to recognize that there's a pattern. What's useful is that we can use this pattern. We can use it to solve basically any quadratic. So here's an example of use. Okay, so we want to solve I'll give us x squared plus 10x minus 9 is equal to sorry, I want to make sure this works out kind of nicely, right? So I'm trying to make something up here really quick. I think if I do minus 18. Okay, let's see how this works out. I might get it. It might not work out as nicely as I wanted to. It'll still work. The numbers just might be wonky. Here is a random quadratic, right? It doesn't mean anything. I completely made it up. However, it is a quadratic equation, right? Why is it a quadratic? Because we have our variable squared. And that's basically all you need. If the variable is cubed, it would be a cubic. If there's no squared, just an x, we call that linear. This one is a quadratic. And we have a quadratic in standard form here, and it's equal to something else. So to solve it, we're just trying to figure out what value of x would make this equation true, right? And like I mentioned yesterday, there's lots of ways to solve a quadratic equation. You could use a quadratic formula. You could factor it potentially. You could graph it. We're going to use this completing the square method. We're going to use the pattern we just observed about a perfect square quadratic. So first thing we do, is this a perfect square quadratic? Is half of our middle term. So the easiest thing to do is just figure out what your b value is. B is going to be the middle term over 2. So it's going to be 5. 5 squared, and then we can also write b squared so we know what it is. B squared is just going to be 5 squared, which is 25. The b is always half of the middle term, so that can be your very first step. So right off the bat, we can see this isn't a perfect square. It doesn't mean we're out of luck for this technique, though, because here's what we do. First thing we'll do is we will move imperfect constant. So we're going to we have this x squared plus 10x minus 9 equals negative 18. And this constant right here, it's the imperfect part. So we're going to add 9 to both sides. That'll get rid of it on this side, and we'll add it over there. So we have x squared plus 10x equals, on this side, we have negative 9. And I left a little bit of space. So this still isn't a perfect square, but now we know what number would make it a perfect square. So that's our next step. We're just going to add, oh, I guess I'll write that down. Here, let's move this over. I didn't need to leave space at this step just yet. Okay, so now our next step is going to be to add in the perfect square. Oops. Constant. So we're going to take x squared plus 10x, and we're going to add in that 25 because we know that's the value that makes this a perfect square. But remember, anything we do to one side of the equation, we have to do to the other side. So we'll also add in 25 there. And remember, algebraically, if you add something to one side and add it to the other, you're totally allowed to do that. You're allowed to add any arbitrary number you want. We could have added 1,000 to both sides. It wouldn't have been helpful, but we still could have done it, and we still would have ended up with a correct equation, just not a useful equation, right? But this 25, we're being strategic about the number we're adding in because we know this makes it a perfect square. Now, half of the middle term is 5. 5 squared is 25. This is a perfect square. Perfect square. So now we can rewrite the quadratic in factored form. And we know exactly how that factored form is going to look. It's going to look like x plus the b value plus 5. That's our b value squared. And that's how it always looks. That's why we wanted to make this a perfect square, because it factors really nicely. And then on the other side, it's going to equal negative 9 plus 25. That's 16. And now check this out. This becomes very straightforward to solve. And now we solve as normal. So what do we need to do to solve this? Well, we have this square on the outside. So let's get rid of that. That'll cancel out there, which means we have to take a square root of that side. This is really important. Remember, whenever you take a square root as part of algebra, you get both a positive and a negative number. So this will be plus or minus 4, and I'll make a little note here. Maybe I'll put it kind of in between. Remember, square roots always give 2 values, plus or minus. So that's where the plus or minus comes from. Plus or minus. So yeah. So now we can, what I like to do when you have a plus or minus and you're still doing some algebra is I like to split it. I think that's a really good way to deal with it, right? So we're going to do x plus 5 equals positive 4 and x plus 5 equals negative 4. If we didn't have any more work to do, we could just leave it. We could just leave it as plus or minus 4, but we know we're going to still deal with that 5. How will we deal with it? We'll subtract it. minus 5 cancels out there. What's nice is both of these problems have, even though we have to split it into two problems at this stage, both problems have the same steps. And so over here, 4 minus 5, x equals negative 1. Over here, negative 4 minus 5, x equals negative 9. And those are our solutions. What does that mean that those are our solutions? It means if we go back to our original quadratic up here, if we plug in a negative 1, it'll be a true equation. The left side will equal the right side. If we plug in negative 9 and do it, it'll work out too. Let's check. It's always a good idea to check. So we'll check x equals negative 1. So that tells us, here, I'm going to write it like this. So we're going to get negative 1 squared. What was it? Plus 9? Plus 10. Duh. Plus, and actually, here's what I'm going to do for us. I'm going to write the equation here. Check x squared plus 10x minus 9 equals negative 18. Okay, so that's the equation we're checking. So we're going to plug negative 1 in for all of the x's. So that's what I'm doing here. Plus 10 times, again, a negative 1 minus 9 equals negative 18. So negative 1 squared, that's just 1. 10 times negative 1, that's just negative 10 minus 9 equals negative 18. 1 minus 10 is negative 9. Negative 9 minus 9 is negative 18. Excellent. That one checked. And now we can check our other one. X equals negative 9. Let's see what happens there. So we'll do negative 9 squared plus 10 times negative 9 minus 9 equals negative 18. Here, let me raise that up a little bit so y'all can see it. Negative 9 squared, negative 9 times negative 9 is positive 81. 10 times negative 9 is negative 90 minus 9. 81 minus 90, that's negative 9 minus 9. Oh, look where we're at. We recognize that. Negative 18 equals negative 18. Now, we know this works because we got negative 18 equals negative 18. If you got any other number equals a number that's not that number, that tells you something went wrong. Now, it could have been your arithmetic when you're checking your answer. So that's the very first thing to check is like, wait a second, did I do my arithmetic in my check correctly? So go back and look through it. If it doesn't, maybe you rerun it. On tests, I highly, highly recommend you check your answers because it's a free way to not get the problem wrong. It's a free way to not miss some points. It does take more work, but the more you do this sort of stuff, the more you check your answer and go through that extra work, the less work it ultimately ends up feeling like. So that's how we use completing the square to solve a quadratic equation. Here's why we call it completing the square. It's this step right here where we add in the perfect square constant. This is the completing the square, right? We took a thing that wasn't a complete square, a perfect square, and we made it one. We completed it. All we had to do that was add in a number here and just remember to add it to the other side because of algebra. That way both sides continue to be equal to each other. And then because we added in just the perfect value, we could instantly factor it into this more easily solvable form. And in fact, that is the idea behind a lot of math techniques, is understanding some patterns so that you can take advantage of them to take a thing that looks complicated and make it simpler. That's the strategy that underlies so many math processes. That's what so many of them ultimately come down to, is recognizing a numerical pattern, an algebraic pattern, some sort of mathematical pattern, recognizing it, and then using it strategically to take something complicated and make it simpler so that you can work it through with basic techniques. Nobody really wants to do hard math step after hard math step after hard math step. If we can do one hard math step or two hard math steps to then take something and turn it into something where we can use much easier, simpler math steps, we're going to do that every single time. Yeah, should we let's do the example from yesterday. What did I call this little section? I called this example of use. So let's use completing the square to solve yesterday's quadratic. Okay, see you. I'm actually gonna take this more complicated version up here. So it was, oops. Oh my gosh, 60C plus 600 equals C squared plus 60C plus 20C plus 20C plus 20C. Okay, there we go. That's our quadratic from yesterday. This is a quadratic equation. It has a variable squared in it, and then it has another variable in it as well, but the largest exponent is a 2, so it is a quadratic. So here's what we want to do. Our very first step is get variables on one side, constants on the other. When I say a constant, I just mean a number like this 600 that isn't being multiplied or divided by a variable. That's what makes it constant. That 600 is always 600. This 60, while the 60 is always a 60, this value right here, it depends on what C is. It varies, right? So this entire term is variable. So actually, maybe it'd be more to be really accurate and complete, get variable terms on one side, constant terms on the other. Okay, so that's our step. So if we have this, oops, I'm supposed to be black. If we have this 60C plus 600 equals C squared plus 20C. I'm going to double check really quick that I copied that down correctly. Okay. Just because I want to make sure we get the same answers as yesterday. Okay, so there we go. So notice we have our C squared is already over here, and it's positive, and it doesn't have a number in front of the variable, just like we want. So what's going to be easiest is to go ahead and just move this 60C over here by subtracting it. It's positive 60C, so we'll subtract it. So then we get 600 on this side equals c squared minus 40c on this side. Easy. So now we have the variable terms on the right and the constant terms on the others on the left. And we could flip these. If you like to have your variables on the right, remember, you can always just swap the sides of an equation without changing anything else about it. But we'll leave it like this just for right now, just for the practice of getting comfortable, working with equations in any form. And now, so we don't even have a constant term over here that we have to get out of the way. We can just ask ourselves, okay, so what is the b value and the b squared value? Well, b is always going to be half of the term multiplying your non-squared variable. We call it the middle term because if there was a constant, it would be over here, right? So it's just going to be negative 40. The negative's important, so always pay attention to your signs. Negative 40 over 2. It's always the number times the single variable divided by 2, which is going to be negative 20. Excellent. B squared then, well, that's just negative 20 squared. Negative 20 times negative 20 is positive 400. Excellent. Okay. So now that we know the value that would make this a perfect square, we just add perfect square value. We complete the square to both sides. Completing the square. So we will take our 600 that's over here, and we'll do plus 400. Over here, we'll do c squared minus 40c. We'll also do plus 400, like so. And now we can simplify both sides. Hold on a sec. Something seems off to me. 1,000 square root. Oh, wait, no, that works out perfect. Let's make that orange. Boom. Simplify both sides. So the left-hand side, 600 plus 400 is 1,000. Over here, remember, this is the whole reason we did this is because this is now a perfect square, and a perfect square can be written as the variable plus b. In our case, b is negative 20 squared. And there we go. Simple as that. And now solve. So 1,000 equals c minus 20 squared. How are we going to solve that? Well, always got to get rid of that square first by taking a square root. The square root of 1,000, I'm just going to, it's like 63 point something. Why did I say 63? That'd be the square root of 2,000. Or 4,000. That'd be the square root of 4,000. Anyway, it's actually 31. So this, I'm going to give us an approximation. Oops. 31.62 on this side. But remember, plus or minus, right? We took a square root, so you always get plus or minus, equals c minus 20. So we have this plus or minus, but we still have some work we need to do. So we'll split it up into 31.62 equals c minus 20 and negative 31.62 equals c minus 20. I bet that's behind my picture, isn't it? Not quite. So simple last steps. We'll add 20 to both sides of both equations and see what we end up with. This is going to give us 51.62, and this is going to give us negative 8.3. Oh, wait, no, plus 20, it's going to give us negative 11.62. I thought I was doing 40 in my head for some reason. And there we go. Does that match? And so I just use this as an example. Quadratic completely removed it from the problem yesterday. These numbers actually meant something. 51.62 and negative 11.62. Oh, I rounded to 6.3 yesterday for some reason. I wonder. Yeah, well, that's just that's a rounding difference. And yeah, 11.6263 and 51.6263. That small little difference is due to a rounding area. It's actually a lot more decimals. Regardless, our final answer that we would round this to about 52 minutes is the same. Excellent. Well, there we go. So notice we did exactly the same thing with this problem, right? We got the variables. We separated the variable terms from the constant terms. We did that so that we had room to very easily just add in the perfect square value, which is always half of the coefficient of the middle term, the linear term, the single variable term. We just take that value, divide it in half, then we square it, and that's the perfect number. And that puts it in exactly the form that a perfect square polynomial is in, quadratic is in when it's in standard form. And so now this is a perfect square polynomial. And over here, by adding in that 400, we've adjusted this side so that the equation stays equal so that we can then take advantage of this. And the whole reason we do this, the whole reason somebody might go through this process, and once you learn how to do it, it's actually really, really fast. And in fact, once you learn how to do it, this is a way that people who solve quadratics in their head, this is often, I think, the technique they're using. Because it just gives you always have minimal numbers that you have to keep track of. You have to keep track of the constant on one side, right? And you have to keep track of what your B value is over here. And then you have to do some in-between values that you have to process really quick, but once you've processed them, you can just forget about them. So it's only a couple numbers that you ever really have to remember. Yeah. These can get more complicated, right? So like some things that add in complications. What if the middle number isn't even? Then you're either gonna have a decimal or a fraction that you have to deal with. And yeah, if you don't want to do that, then maybe you want to use quadratic formula instead, right? If there is a coefficient in front of the leading term, the squared term, we can get rid of it by just dividing everything by that value. And again, that might create fractions, though. I was working with a student day before, or yesterday, I guess it must have been. And we're actually working on some completing the square things. And yeah, one of the problems, there was a leading term. We had to divide it out. And that just left us with kind of messy fractions throughout the whole thing. But the process is exactly the same. The fractions don't actually change anything. All that ultimately changes is sort of when you add to both sides, you add this value in. If it's a fraction, well, then you're gonna have to do some fraction addition really quick, right? And so it adds little bits of stuff at every step where you're just dealing with the fractions. That is completing the square, though. Let's check for question submissions. Okay. I don't see nothing. Awesome. Trying to think if there's anything else really to say about this. Completing the square. I remember when I was, in the classroom, it was always sort of a kind of a hard time during the term, right? Like it's a thing students always kind of struggle with. And I think that's because we overcomplicate it when we try to teach it in school, in a classroom. It really is just recognizing a pattern. And so students already have to understand like how you multiply polynomials like this, right? Like they have to be pretty comfortable with that. But I think there's all sorts of like these ways that we can try to like make sense of it that add in a whole bunch of other stuff. And I think for the purposes of students in school, we're teaching it as a technique. We're teaching it as a tool. The students don't necessarily get anything out of teaching them the geometric interpretation of this, right? And there's a literal geometric square that you can use to demonstrate this, but it sort of takes teaching a whole bunch of other stuff just to even make sense of that. There's also more complicated ways to do the steps of completing the square. I'm always a fan of keeping it as simple as possible, right? And so, and if you're still not sure about this, like, please let me know where in the process things feel weird. Does this line right here, when I write x plus b squared equals x plus b times x plus b, does that not make sense why these two things are equal to each other? Maybe that does make sense, but how it turns from this into this last line, maybe that's a little bit opaque to you, right? I encourage you, really sort of, when you're struggling with math, it can be super easy to just say, oh, I just don't get it, and leave it at that. You're like, I didn't understand it. But oftentimes, here's my experience with working with students. Oftentimes, there's just one little thing that didn't make sense, that sort of, and that one thing can absolutely keep the whole lesson, the whole idea from clicking into place, from making sense to the student. However, if we can clarify that one actual piece, now all of a sudden, not only does the student understand that little piece, they understand the whole thing. Granted, you probably have to teach the whole thing again, but like that's why I like to keep it simple and straightforward, is because then the reteaching is simple and straightforward, right? So my advice to students is, when you're looking at stuff like this, ask yourself, do I understand this line? You're like, yeah, I know something squared is just that thing times itself. Easy. Okay, I understand why that's written that way. Do you understand how we got to this next line? Do you understand how to actually multiply these? Do you understand why we have an x squared, why we have a b squared, why we have two bx's in there? Right? Where did those come from? But if you understand that, that's great. You can move on to the next line, and then you're like, oh, well, and I see that, okay, 2bx is bx plus bx. We could write that as 2bx. That makes sense, because 2 times bx just means bx plus bx. Those mean the same thing. So this is a simplification. It's combining like terms. You're like, okay, then I understand that. Well, there's nothing else to this. That means you do actually understand this whole process. And then from there, you're like, okay, so you understand how that all goes together. The key, I could have just written x plus b squared equals this last line. I could have just written that out and said, here's a pattern. But I wanted you to see where the pattern comes from. I wanted you to be able to recreate the pattern on your own if you needed to. But then once we know that this is true, then we can look at this and say, wait, there's a pattern here. Anytime half of this middle value, so half of 2b is just b, and then since half of 2b is b, then this middle term b squared. So that tells us anytime half of the middle term squared is the last term, then it's a perfect square. And you automatically know you can move from here right to there. And that's what we did whenever we were solving the problems. Once we created the perfect square, once we completed the square, we immediately just turned it into this factored form. We didn't bother to go through an X or a factoring process, because we don't need to. We know for sure how it factors because we forced it to. Right? And if you're like, oh, okay, I can understand like the strategy of that. Well, now you're starting to get the technique of completing the square. Anyway, my whole point is, when you're feeling stuck, and it's okay to take a break and just throw your hands up and say, oh, I just don't get it. But at some point, come back to it and say, okay, but what do I get? Because chances are you understand the majority of it, the vast majority of it. There's just a couple sticking points, right? And you can kind of go through. But if you're having trouble figuring that out, that's a great question to ask me. You can say, can you help me figure out where I'm getting stuck? And give me a problem to work through, or give me a topic that you're talking about in class, send it in, submit it. And then I'll go through and then you can sort of figure out, oh, it's right here. You did this step, but I don't understand how or why you did that. I don't understand how I would have known to do that. And then that's a follow-up question you can send me. Or if you happen to be able to watch this live, that's a follow-up question you can put in chat, right? You can, if you're watching live, you can say, oh, wait, right there. That I'm not sure what's happening right there. And you can interrupt me and I can go a little bit more into it. And that's honestly the same thing you can do in class, but I understand in class that requires you to raise your hand. And get your teacher's attention. It requires your teacher to notice you. And then it requires you to try to articulate where you're stuck in front of all of your peers. And I understand that that's an uncomfortable process. Some students don't mind that process, but I know other students really, really do. So my hope is that this is a space where you can do that. You can sort of do that introspection into your own understanding, and sort of shine some light on it. And I'm here to help you with that, right? Like, yeah, let me know how I can help you do that process. And if you realize those places where you're stuck and you want to figure out how to get unstuck from them, you can send that in. You can, if I got a question that was like, hey, so I've realized I'm really, really stuck on this particular part of completing the square or whatever else, right? Oh my gosh, a specific question like that is amazing to get. But don't worry if you don't have a specific question. If your question is vague and just like, please help, that's totally fine too. I'm totally happy to do that. Sometimes you need somebody to help you get going before you can dig in like this, right? This is good. I think this was a good session. I will be back Sunday, the 25th. That will be the morning stream, Sunday at 11 a.m. So yeah, so hopefully you'll have had a chance Friday or Saturday to look at any weekend math homework you have. I know the semester for my local district 4J is ending at the end of this month. So I'm sure there's tests and things next week for a lot of students. So let me know if you have any questions about test review, anything like that. I'm more than happy to help. Yeah, I think I'm going to call it there. I mean, there's still what would be a little bit of time left in my scheduled time, but I don't have anything else to talk about, and there's no questions. So I think I'm just going to call it and tell you all, I hope you have a very nice day, a great rest of your week. Please send in your questions anytime at all. The next time I'll sit down and look at questions will be Sunday. If you ever are in a position where you're like, oh, like your next stream will be kind of too late for me, like that's too, like I need an answer, I need a response before then, you can send me an email and say it's urgent, or you can, in your problem description in the form, you can say this is urgent. And I'll do basically the same thing I'm doing here. I'll work out some notes and I'll send you a link to the notes. There won't be a corresponding like video to go with it, but oftentimes just the notes can be really helpful. And then you can email me back clarifying questions, and we can do it sort of in asynchronous nature like that. So just because I'm not scheduled to do a stream doesn't mean I can't help you before that stream. You just got to let me know that you need a response before the next stream. Yeah, I hope this is helpful. I will be back Sunday at 11 a.m. PST. I'm on the West Coast here. I hope you all have a great rest of your week. Bye.